Today in stats, we talked about simulations, and I like to do a four-step process. We start by kind of titling our simulation. We're going to be testing a scenario. You can read one down at the bottom of the page. And we want to test whether or not we can trust what happened. And that's the state step. The plan step, we're going to describe what we're about to do, how we're going to conduct the simulation. The do step, obviously, we're actually going to do it. And then we got to say something about it. Conclusion. We'll say whether or not we expect that, for example, this golden ticket parking lottery happened in reality. So maybe hit pause and read through that and think about it and hit play. So we have 95 students that can park, and we have a person from student council. They select 2 people to be in these golden ticket parking places, 2 spots. 28 of those 95 happen to be from AP Stats, and in one random drawing, 2 of them happen to be selected. So people are doubting whether or not this was a possibility. They think that the person that drew names was picking friends or something. I don't know. So the state step, is it plausible that that happened, that this was carried out fairly? On the plan step, we want to describe the process of what we're about to do. So in the textbook, there are a bunch of ways to do this. We could use a random number generator, but I want to show you all finally, after talking about it, how to use this random number table. So all these numbers are random. Some computer spit them out using a random integer program. And they give them line numbers over here on the left. What you do is you randomly pick a line and you move left to right, or I guess you can move any direction you want. They're all random as long as you're consistent with your process. And each number or collection of numbers can represent a trial. And you want to do something many, many times, like the process over and over again. And that's going to test whether or not what really happened was surprising or not surprising. So we can simulate a process of selecting 2 random students, and we can do that a bunch of times. Here in the notes, I picked 25 times. We're going to do 25 trials just for the sake of time, because we don't want to be here all day. So we're going to run through this 25 times. Let's write out a plan, and then I'll show you how to use it. So number, and there's similarities to random number generator and the hat method. Number students 1 to 95. That represents all the students that possibly can get a parking place. When I run a trial and select students, I want to know whether or not I got stat students or not. So I need to pick a nice, easy to identify 28 numbers that represent stat students. Let's let numbers 1 to 28 resemble AP Stats students. Use a random number table let me slow down. Let me explain myself here before I write the next phrase. Let's go to the random number table again. So I was looking at this. It's a bad picture, but yet look at line 110. That's pretty flat. That's easy to read. I want to move left to right, go one number at a time, and select students. So one trial consists of selecting 2 students. I have a problem though if I just say, I'm looking at line 110, so find that spot on the page. I'm moving left to right. It's wrong if I say student 3 and student 8 are in my first simulation, my first trial. Yeah, 3 and 8 happen first, but think about what happens as I move left to right. 3 and 8 would be my first trial. Second trial, I get 4. Then I have a second 4. That's not really bad, but yet I don't want to duplicate. So I'm going to throw that second 4 out. So trial 2 would be 4 and 8. Then trial 3 would be 4 and 8 again. Then 7 and 8. Then 9 and 1. 8 and 3. 3 and 8. There are a lot of people that have 0 chance of being in my sample. I need to go 2 digits at a time, meaning the first student, first student is represented by 0, 1, and then naturally 95th is represented by 95. It's a catch to using the random number table. You need to move as many digits at a time as the largest value in your range of numbers. So like, for example, if there were 100 students, I would need to move 3 digits at a time, which would be a big headache because I would need to ignore a lot of numbers. But if I'm moving 2 at a time, there's only 5 number combinations I need to ignore. So let's write this out. Use a random number table, letting each 2 digits resemble 1 student, one trial consists of 2 students. And we'll practice this in just a second. Sometimes just talking through it makes no sense. What if I get number 96? I need to know what to do. What if I get 2 of the same student in one trial? So if numbers repeat within a trial, throw out or skip, something like that. Let's write a period. Let's write pick next. I feel like I said it better in third period. If numbers 96 to 00, so that's talking about 96, 97, 98, 99, and 00, then ignore, maybe I should have used that word a second ago instead of throw out, then ignore and pick next. Do this for 25 trials. I mean, the more the better. We could be here all day. We could do 1,000,000 trials if we want, but we don't want to do that. I just want to demonstrate how to use a random number table and how to do a simulation. So I did it already. You may have to pause the screen. Let me scroll down. I don't know if you want to do a screenshot and try and follow along. In third period, we did line 132. So I got that at the top of the screen. And we had to go, if I remember right, all the way down to line 134. So as you're reading left to right, these breaks in the columns mean nothing. And if I use all the numbers on line 132, I'm just going to drop right down to line 133 and keep going. So when I did that, let me pull up what we had. I had it earlier. We got something like this. So if you need to rewind and look at line 132, and as I go at 2 digits at a time, that's what happens. And I already concluded and everything. So there it all is. The circles, trial 12, 15, 16, and 18, those are occurrences where 2 stat students were selected, like trial 12. 18 and 7, those 2 numbers are within 1 to 28. Remember in our plan step we said those numbers resemble stat students. So the places where I circled, those are the events in question. Because remember back at the very beginning, we were concerned about 2 stat students being selected. So that's what I circled. And that's why I did 4 divided by 25, because it happened 4 times out of my 25 tries. 16% is not shocking. It's larger than 5%. So this was somewhat expected. It wasn't surprising because it happened 16% of the time. So I'm going to say the lottery was probably okay. Now, if you pick a different line and you get a shocking proportion, that's probably just because we had a small number of trials, 25. If we did this 100 times, if we got a computer program to run this thing 1,000,000 times, I bet regardless of the line you pick, we're going to get about the same proportion of times and we'll have better data. But for the sake of time, we only did 25. So it is very possible that if you pick a different line, you get a opposite conclusion. So hope that makes sense. I will see y'all in class.